So with MVS, we see the introduction of a new storage layout, in addition to the concept of an address space. In this way, each unit of work would now be assigned an address space, which made it appear as if that work was the only thing running in the system. Each address space would have a virtual map of which pages were associated with it, so that when work was running, the virtual storage map would be loaded that would reflect that work. Prior to MVS, we would have been restricted to the amount of memory that was available after all the system components were accounted for. So if 16 megabytes was the maximum, perhaps half of that was available for the operating system, so that would leave 8 megabytes available to be shared among all the other work that needed to run. So if I had 8 jobs to run, then each could maximally use 1 megabyte of virtual memory. However, by going to the address space design, each job would have access to the full 8 megabytes, since it was only virtual mapping anyway. So it didn't matter if I had 8 megabytes and another job had the same virtual 8 megabytes. The only thing that would matter is if our use of the underlying real memory became too high, then we might suffer performance problems due to paging, but we could still run the work. This gave rise to a lot of implementations that focused on managing the performance of paging. So in some high-usage systems, it was not uncommon to have systems that were moving 200 to 300 pages per second through the system. This was clearly a performance impact, but it also allowed for larger units of work to run, which could be protected to some degree, and different types of work to run as well. So it was a reasonable compromise at that time. From this environment, MVS XA was introduced, which represented a change in the architecture from 24-bit addresses to 31-bit addresses. This meant the largest address that could be used was a little more than 2 billion bytes, or 2 gigabytes. Note that this implementation was 31 bits and not the 32 bits we normally associated with our PCs. The reason was that 1 bit was reserved to indicate whether the system was operating in 24-bit mode or 31-bit mode. MVS XA further modified the designated storage locations by mirroring those that had existed in the previous release of MVS by creating an extended version for programs that could use 31-bit addresses. This opened the way to suddenly be able to increase the amount of RAM memory on these systems from 16 meg to 2 gigabytes and radically changed how these systems performed and opened them up for larger and larger software implementations. The only issue that had to be addressed was that some programs were written with the expectation of 24-bit addresses, while others could take advantage of 31-bit addresses. As a result, IBM supported bimodal programs, or programs that could run in either addressing mode. This division introduced the concept of a line, which was the 16 megabyte line, so that programs that used 24-bit would run below the line, while those that used 31-bit ran above the line. This ensured that the new capabilities would be readily exploited, but also that older software that might not be capable would continue to run without modification. In this way, exploitation could occur without major conversion efforts or program rewrites. This screen capture shows the various assigned areas of the system with their beginning and ending addresses, as well as how large each of these areas is. While this may look complicated, it is important to remember that all numbers are typically displayed in hexadecimal, so we can see each area of the virtual storage identified on the left with the beginning memory address and the ending address specified. The size of these areas is represented in the length column in hexadecimal, as well as the number of bytes. Those areas marked as PVT and ePVT indicate the memory available for address spaces to run programs in, with both the 24-bit below the line and 31-bit above the line areas.